Thanks everyone for tuning in. So today, myself and my senior colleague Prashanth will be talking about Machine Controller Manager, the out of tree way. So the agenda is we will do a quick recap of MCM, followed by an explanation about the approach of out of tree MCM. Then we will talk about how to go about implementing MCM out of tree, given for your own cloud provider as such. And then we will also talk about MCM out of tree in the context of Gardener. Okay, to begin with MCM recap. So Machine Controller Manager is the best known automation to manage the machines because it treats machines as a first-class citizens of Kubernetes cluster with a declarative API and also supports various cloud providers. It is very easy to integrate MCM with components like cluster autoscaler, node problem detectors, etc. And as well, scaling and upgrading of the machines at will is just like any other rolling updates in Kubernetes. So this makes it very convenient and also cool to employ MCM for the management of the machines in our Kubernetes clusters. So MCM consumes the following custom resources and resources: the machine class. So machine class is a kind of a template or a blueprint of the machines that we would be managing on cloud with the MCM. Then it's machine deployment, machine set machines, which are very much analogous to the deployment, replica set, and the pods resources of the native Kubernetes. And these three custom resources have their own corresponding controllers called the machine deployment controller, machine set controller, machines controller. MCM also consumes the native Kubernetes secrets, and these secrets would typically have or store sensitive data like the cloud provider credentials and also some bootstrap scripts in them. So MCM started with an in-tree approach, that is, the machine management logic for various cloud providers runs as a single binary and hence in-tree. And Machine Controller Manager would typically need two Kubernetes clusters, one control cluster and target cluster. Control cluster is the cluster where all the CRDs and the machine controller manager would be deployed, and target cluster would be the cluster in the scope where we would want to manage the machines. So the flow would be something like this. In the control cluster, we would create machine class and secrets, which will be stored in etcd by the API server. And then when we create the machine deployment controller will reconcile to create the corresponding machine set. And then once these machine sets are created, the machine set controller will reconcile to create the corresponding machine objects. And once these machine objects are reconciled by machine controller, it actually talks to the cloud provider API using the provider secrets, the credentials and all, in order to create the actual virtual machines on the cloud provider. And then it also runs the bootstrap scripts, which will make the virtual machines talk to the KCM, and then they will register themselves as nodes. And when these nodes start sending the heartbeats or the health checks to the machine controller will update the status of these backing machine objects from pending to running. So this is a typical workflow of in-tree MCM. And these three controllers, machine deployment controller, machine set controller, machine controller, together constitute machine controller manager. So now already you might have figured it out that given that the support or the implementation or the logic of all these cloud providers, various cloud providers runs as a single binary, it would be difficult for development and also maintenance, right? So in order to ease the development activity, in order to accelerate the development, in order to ease the maintenance, and also to provide more flexibility to hyperscaler providers, we came up with something called as MCM out of tree. So MCM out of tree has evolved from in-tree. So there were several design approaches that were experimented in order to adopt the best one. Prashant will now explain various approaches in the MCM out of tree. Over to you, Prashant.
Yeah. Hi guys. So I'll just talk about the approaches for out of tree that we brainstormed while going about it. So first I'll start with the MCM components. I think Samarth spoke about most of them earlier. I'll just recap. First, we start with the machine controller, which is responsible for managing the machine CRD's lifecycle. And then we have the machine set controller, which is responsible for the machine set of CRD. And then we have the machine deployment controller, which is responsible for the lifecycle of the machine deployment. CRD. Lastly, we also have this safety controller, which basically has a few checks, and one of the checks being basically to delete any orphan VMs if created. Maybe it could be some bug in the code or bug at the cloud provider, where if some orphan resources turn up, we kind of delete them with specific tagging. All these together make up the MCM, but in addition to this, the machine controller is also made up of three different components itself. One is the core reconciliation logic, which basically takes care of the management of the machine cycle, machine object cycle. Then there is this health check mechanism, which basically makes sure the node is healthy and I mean, kind of marks the nodes as unhealthy if some health check fails. We've even integrated it with the node problem detector to identify issues with the node issues reported by the NPD. And then finally, there is this cloud provider specific code that is uh, typically SDK calls to the different cloud providers to manage these machines. Say, for example, creation, deletion, getting the status, and things like that. So this is the typical architecture. So what we did with approach one is this was our first model that we looked up, and this is very similar to how the CSI drivers work in Kubernetes. So what we did is we moved the provider specific code out into a separate binary, and so we retained the all the components of the MCM as it was before in the single binary, but we moved the provider specific code to another one, which you see on the right side of the screen. And the communication between these components were through gRPC, where the MCM was a gRPC client and there was a gRPC server by the cloud specific logic. So, and this gRPC calls had an interface like, for example, create, delete, list machines and things like that. And even the safety controller, which say, for example, identifies duplicate VMs or something, would issue delete calls using gRPC. This model worked well. However, there was a limitation which over discussion, several rounds of discussion, we felt it was less extensible in the sense that any implementer implementing this can only implement these functions and cannot really uh, um, uh, modify the core logic. Also, there was this dependency of learning gRPC itself, which is not much, I would agree, but we thought to keep it more native to the Kubernetes way and thought to relook at this approach. And hence we went with this. Hence we thought about the second approach, which is the controller approach, where we moved all the machine related logic out into a separate binary. And these are Samarth, these are two different binaries. Basically, the one on the left, you see the MCM takes care of the machine deployment and the machine set CRDs, and anything related to the machines comes under the machine controller on the right. And they are they basically coordinate with each other using the CRDs itself, the statuses on the CRDs. And this was more native to the Kubernetes approach. But one flaw with this approach was still that, you know what would have happened is, say for example, there's a lot of common code, and once duplicated would like, say for example, if you had different providers implementing the machine controller, let's say there's AWS, there's a GCP and XYZ provider, right? And say for example, there was an update in the core reconciliation logic, and or there was a bug fix. So each provider would have to propagate his fix separately. So we went with something of an approach between one and two. If you go somewhat to the next, where we took the approach three, where we took the common logic out and we created a shared binary out of it. And this shared binary is then imported by the machine controllers to basically, it just went similar to the Gardner extensions, the Gardner extensibility. And this gives us the flexibility to basically the providers to not bother too much about the core logic, but at the same time have the flexibility to modify it. So providers can either reuse the shared library, or if they want to make changes, they can contribute to the shared library, or even, at the worst case, if there's something very specific to provider logic, they can always have it as, instead of using the core shared library packages, they can just create one for themselves. So yeah, this is the approach we have finally picked up to. And yeah, this is the same diagram that Samarth showed you earlier. The difference is, now if you see, the machine controller manager doesn't host the machine controller logic. The machine controller is a separate binary now, and each provider will have its separate binary for the controller parts of it. And yeah, while doing this, something we also did is, initially we had different CRDs for different machine classes. So AWS, Azure, or any provider that implements had to write their own CRDs with their spec. So we kind of merged all of this and came up and went with a single CRD for the machine class, and the provider field in it, provider, and there's a provider and provider spec field which differentiates, yeah, which provider it belongs to. Say for example, this is one sample CRD that we had earlier. On the left you can see there's a AWS machine class CRD, and we had a spec section. We have moved it to something like this on the right, where there's a kind machine class, and the kind is now generic machine classes. And then yeah, all the spec section goes under the provider spec. And then we still have a field called secret ref, which yeah, I mean, I guess I missed to share on the left, but yeah, basically the secret ref was under the spec, but we have moved it onto a separate field now. So this is something. And there is also a provider field which probably is also missed on the right. Yeah. So this is how it looks like, the old and new one. So these are two changes that comes in with the out of tree approach. Samantha, you can move ahead.
Okay, thank you, Prashant.
Yeah. Thanks. That's from my side.
Okay, so moving ahead, we will now look at, if at all we had to start implementing MCM out of tree for our own cloud provider, then how to go about it. So there is a verbose documentation we have done, which can be referred in our machine controller manager repository. Okay, and I'll just probably quickly show it. So this is the page where we have documented all the steps in order to start with. And then once step in specific has a point called clone this repository, which is a sample provider repository that we have created in order to begin with, right? So it makes like all the prerequisites, it just keeps it in place, and the developer can just get started with it. And one important aspect of this is to implement the driver interface, which has a few methods: create machine, delete machine, get machine status, list machines, get volume IDs, and generate machine class for migration. And these methods pretty much do what the name says. So create machine creates the VM. So those particular logic will go there, and the OOT driver will have to implement these methods. So the input parameters are like create machine request, machine delete machine request, get machine status request. So you can see the structure of those things over here. So create machine request would have the machine object from whom the VM is to be created. So every machine object is the backing machine object for every VM that we create on the cloud provider. Then machine class, that is a machine class that backs the machine object in turn. And then the secret that we have to hold the sensitive data like credentials, etc. And like this, the create machine response would be the provider ID, which would be some unique identification code from the cloud provider. Then the node name, the node object name with which it registers to the Kubernetes, and the last known state. So like this, these structures would be utilized in order to implement these interfaces. Okay, so we are we covered the documentation and the sample repository part, and also we looked at the interface, and then yes. So yeah, now talking about machine control manager in the context of Gardener. So when it was in tree MCM, we had what we known as the Gardener extension provider, which is specific to the cloud provider again. So based on the cloud provider on which the seed is created, we would deploy this Gardener extension provider of that particular cloud provider, which would in turn deploy the control plane of the shoot cluster. And control plane typically includes MCM and its associated CRDs. So this is how MCM in tree would work with Gardener. And with out of tree, what happens is the MCM is deployed And also the MCM or the machine controller for the specific cloud provider, that is the out of tree MCM, will also be deployed along with its associated CRDs. And these controllers, that is the machine controller for the provider XYZ and the machine controller manager, will run as independent containers, however, within a single pod. So this is how it works in MCM in the Gardener context. And also, there are migration PRs that are being working on. So if you are using MCM independently and you want to migrate from in-tree ecosystem to the out-of-tree ecosystem, then you can very well employ these work that are being done. So currently in Gardener, the following cloud providers are already using the out-of-tree approach for the vSphere, which even like it just got built with the OOT approach. GCP, AWS, and Ali Cloud have been migrated from in-tree to out-of-tree. And the providers which are currently in migration are Azure and OpenStack. And very soon they should be on Gardener. So yes, this was all about Machine Controller Manager out of tree way. And if you guys have any kind of a queries, you can feel free to raise, and even feel free to communicate or contact us on GitHub issues or even on Slack channels. And also, we request you to join the community and looking forward for collaboration. So thank you.
Yeah. If you have any feedback, any questions, please feel free to share.
Yeah, hi, this is Uwe. Two questions. The first one, have you thought about extracting this health check code from the machine controller? Because it should be all the same, and it is Kubernetes specific, but not VM specific or machine specific.
Wait, just I'm trying to understand what. So yeah, so currently the health check mechanism is tied up with the machine reconcile logic, but there is plan we have plans to move the health check and the drain mechanism into a separate controller if possible, and so that it's done independently and managed independently. Was that what you were hinting at?
Yeah, exactly. Because this has the advantage that the machine controller could also be used to maintain any kind of VM, not only Kubernetes VMs.
Yeah, sure. You're right.
Yeah.
Yeah, that is something that we have in our mind. In fact, the
Yeah.
next step we are trying to do is move the drain logic out, and if that also works, the next would be the health check. Yes, that is something on our mind. Probably we forgot to mention in the slides.
Okay, then the second question, the extension, as far as I understood, is creating the MCM instance, the generic MCM instance for every shoot separately?
Yes. Currently, yes, that's how it is.
Why?
Yeah, I mean, this was how we had initially developed it, and it that's how it is working currently.
Yeah,
But
I
yes,
know. Yeah.
I understand your concern. Maybe eventually we would like to move the MCM out and keep it common for the entire seed or something.
So far the MCM and the machine controller is configured to maintain only resources in one namespace, correct?
Yes. Currently, yes.
But basically the code is able to handle multiple namespaces.
It will need some updation because initially it wasn't thought in that context and built. But yes, I think this should be possible though.
Yeah, that would be the same way the DNS controller ecosystem is working. So the providers are running only once in a seed and watching all the namespaces for all the shoots to do their work. Yeah, okay.
Yeah.
Yeah, only the machine controller part is something that will be hard to make common, but I think the rest of them, yes, they can be. We should.
Yeah, but even the machine controller for a dedicated type could run once, because it doesn't.
Only after the health check is separate.
Yeah. Okay. Yeah.
Thanks. Yeah, I think that these are things on our mind way, but we still haven't got until there yet because of we take it step by step.
This is not the end of the out of story. Basically, we took that option of completely moving the machine controller as out of tree right now, and then we'll slowly chop it up into smaller ones so that they are then independent.
Yeah, sure, no problem. So thanks.
Thanks.
Thanks.